Now, I'm not going to do any examples of the following segment, but I do want to remind you of some common areas and perimeters and talk quickly about composite shapes. So the common ones you'll need to know, and you may want to just pause this video and write down your own version of these things as I go. The first one is a rectangle. Now, a square is a special type of rectangle, so I'm going to assume you can deal with a square from a rectangle. And in my rectangle, I'm going to say that this is the width and this is the length, but it could be X and Y, it could be A and B, it could be whatever. So the perimeter of this rectangle is equal to width plus length plus width plus length. This is how I do L's to make sure they don't look like ones. 2W plus 2L. The area is just equal to width times length. And there are two formulas. So you'll need to remember the rectangle formula. Now the second one is parallelogram, and actually I say that loosely that you need to remember. I'm going to show you the formula sheet in a minute too and give you some happy news. Parallelogram, it's kind of like a rectangle is a special type of parallelogram that has right angles. So a parallelogram has two pairs of opposite parallel sides. So that's parallel to that, and that's parallel to that. And a rectangle has that property, but also has right angles, and opposite sides in a parallelogram are also equal. And so we don't know a lot about the angles in this parallelogram, but we do know that we can calculate the perimeter if I do, again, something along the lines of length, I'll call this width and length, then the perimeter is again going to be width plus length plus width plus length, which is 2 width plus 2 length. But there's a slightly different formula, and hopefully you've seen the old cut the triangle off the end here, move it over to here, and you get a magic rectangle situation. And if you haven't, have a look a bit wider, but I'm going to tell you that we call this H commonly, and H is the vertical height of the parallelogram. So it's not L. L is the diagonal height, H is the vertical height, and the area of a parallelogram is the vertical height times by the base length, W, and I think it's on the formula it might be BH, so we might be calling this B. So there we go. Anyway, I'll just put that in brackets. So I've used W, maybe I should have used B, but them's the breaks. Trapezium. This one's my favourite. Love a trapezium, and there's some really great things you can do with a trapezium, but for now we're looking at the simple familiar. So I'm just going to tell you how the formula works, and we'll talk about other stuff. Now this is a trapezium. This is what most people think of when they say a trapezium. But a trapezium's only got one major property, and that is that a pair of opposite sides are parallel, and it's got 4 sides. So a trapezium could be this shape over here. Watch this. I draw a side here and a side here, and they're parallel because they're both horizontal. And so if I connect this up to make it a quadrilateral, that's also a trapezium. A trapezium can be anything that looks like any of these shapes. It just has to have one pair of parallel sides. Now in a trapezium, the standard and the norm is that we call the top A and the bottom B. So that's this length and this length. And then we get this vertical height. Now there's not really a standardized formula for perimeter here. To get the perimeter, you've got A and B, you just add them together, but you need these lengths here. And a trapezium doesn't have to be a symmetrical trapezium, it could be like this. And that length is different to that length, and you've got to do a bit of Pythagoras theorem to find them out. So there's no standardized formula. But for area, there is, and the area formula is a half H A plus B. Now, again, when I look at the formula sheet, I can't remember exactly how it's written on the formula sheet, but another way of writing this would be H times A plus B on 2. I've just moved that half under the A plus B, which is probably a little bit more visual because what we're doing is averaging A and B out and then multiplying by height. Now the reason we average A and B out is that if we cut this trapezium here and here, we can flick this triangle up to there, and we can flick this triangle up to here, and we create a rectangle. But the base length of the rectangle is not A or B, it's the average of A and B. So we just need to do that calculation. And lastly, I just want to talk quickly about a triangle. So in a triangle, we've got this special property. Here's my triangle. It works quite nicely. and if we know the base of the triangle and the height of the triangle, then the area is equal to a half base times height, which is really nice, and we can use that. But there might be there's other variations of triangles. So you might get lucky and have a right angle triangle, and a right angle triangle is actually half a rectangle and pretty easy, and it turns out the height is just actually one of the side lengths. So we still get area equals a half base times height. And the other one that we're going to talk about more in class is you could have a triangle like this and your information could be different. So you might have A, B, C, but we don't know our height. Now, this is where we could introduce some pretty clever intuitive trigonometry to calculate the height, but it's pretty intense and it takes a bit of work. So typically, we go back to a formula that's also given to you on the formula sheet, and that formula is called Heron's rule. It's a pretty complex formula, but once you know it, it's really just substitution into what's mathematically not too tricky. So Heron's rule is that the area of a triangle is equal to the square root of, wait for it, S times S minus A times S minus B times S minus C. But what's S? Where S equals A plus B plus C over 2. So that's Heron's rule. Heron, and S is half the perimeter, that means, which is a nice easy way to think about it. And if you work out S first of all, then you can work out the area. And I'll just take you through quickly one pretty basic example of this. So we'll do a nice flat triangle, maybe the worst triangle I've ever drawn. 7, 8 and 10. And then Heron's rule would say that S first of all is equal to 7 plus 8 plus 10 over 2, which is 25 over 2, which is 12.5. So you can work that out, and once you've worked out Heron, the S value, the area is equal to the square root of 12.5 times by 12.5 minus 7 times by 12.5 minus 8 times by 12.5 minus 10. That's equal to the square root of 12.5 times by 5.5 times by 4.5 times by 2.5. And now I'm going to have to go to my trusty calculator, but I'm going to calculate the inside first. So it's 12.5 times 5.5 times 4.5 times 2.5, which is 773.4375, and then I'm going to take a square root of that. Square root 773.4375, and I get 27.81074443 ... which is 27.81. And I don't know my units, so 27.81. I should put units there if I knew them. That's how Heron's formula works. You can see it looks really complex, but it's not that bad once you calculate that S value. And I even threw in a little bit of well, it's now a half, 12.5, not a whole number, which gave me a half, a more complex number there, but it still worked out pretty easily. Okay, so that's our lead-in on this topic. I want to talk to you quickly about composite shapes, but I'm very aware of how long the video is already, and then show you the formula sheet. So just remember the definition of a composite shape is a shape where two shapes have been added together. So a really common example of that is, well actually let's do the normal shape, is this one here, the old house shape. If you asked to find the area or the perimeter of this house shape, you'd just do a little imaginary line there, you calculate area 1 and then area 2. This is going to be where some of the complex familiar questions come from, calculating these areas. Or maybe, a really good complex familiar question would be, well, this is the area of this shape, and we know some of the side lengths, but not all of them, and then you have to backwards design that to work out something that's missing. So that's a composite shape, and now I just want to quickly show you the formula sheet. So we'll have a look at that now. Okay, so here's the formula sheet, and you can see of the formulas we've just spoken about. You have the area of a parallelogram formula, you have the area of a trapezium formula, you have the area of a triangle, and some volume. So we don't have the area of a rectangle. You're going to have to learn that one yourself. We also have Heron's rule. So that's good news. In our next video, we're going to talk about the circle formulas, and that will cover us off on all the area and perimeter. All the best.